One of my viewers asked me about a video I had done a while ago. I repaired a stereo amplifier, and he says, well, how do you test these things once you repair them? How do you determine that they're performing up to the standards? So I said, well, I'll do a short video that'll give you a few suggestions. So what I got here, I've got two Yamaha receivers here, RX V379s. There's two of them, and this one's got a dinghy in it. The other one has a little dinghy. I think they got these on their way into the dumpster, but I'm not sure if they work or not, but we'll test them out and see. But anyway, to test these amplifiers, you need a few basic things. One is you really want to have a dummy load so that you can connect the output of the amplifier up to that. You don't want to connect an unknown amplifier up to your good speakers. That's a good way to blow them up. Especially the woofers. You know, they're connected directly across the outputs, and if you have a shorted output transistor, you may dump one of the rails voltage across the voice coils of your woofers. The tweeters, the smaller speakers, are generally safe because they will have a capacitor in the crossover network that will prevent any DC from getting into the coils. But the woofers, they're vulnerable, and you'll blow those out in a second if you apply, you know, 40, 50, 60 volts across them there. I did another video on building this. This is just a gallon paint can, two heating elements out of a water heater. They're new. And I built a little box for them and put some input-output jacks where I can connect them up to the amplifiers. It's got speaker jacks, and then it's got some RCA jacks so I can connect up to a scope and do some monitoring. Something else that's nice to have is an audio analyzer, but it's not necessary. This is a HP 8903B audio analyzer, and this thing is pretty handy to have. It'll give you an output here. You can set your output frequency, so you can dial in an output, or not dial, but you can punch in an output frequency, both frequency and amplitude, which comes out here. And then across the output of your dummy load, you can monitor on the input here, and this will measure. You can measure the AC level. You can even do sinad measurements in transceivers here. But what I use in this application is a distortion function, and it'll measure your total harmonic distortion on this output here. You can also, this is a 8903E, this is a distortion analyzer, just a basic distortion analyzer, but this unit here does pretty much the same thing. Something else you want is to have true RMS voltmeter. These will measure, actually these have little scopes in them too, which is kind of neat. I really like these. I just picked these up. But anyway, you can measure RMS volts here if you want to calculate your power, you know. P equals E squared over R, so you can calculate the power output by measuring the voltage across your load resistors. And of course you can use DC to measure your output terminals to make sure there's no DC on the outputs. At least no more than a few, you know, millivolts, tens of millivolts here. And these are kind of neat because you also have an oscilloscope that you can measure. So I don't really use these. They're too small really to see, and I basically use them for the meter functions. They're kind of nice. They have a little imitation analog scale and the digital scale too. These were fairly inexpensive. This is a ZT703S and this is a ZT702S. This has one input for the scope and this has two. That's the difference. So anyway, let's hook these up, and I'll start with this unit and I'll run a few tests on it. We'll see if they work. Sometimes when things come out of a dumpster they don't work, but every once in a while I get lucky, so we'll see if we get lucky. If anything else, we got two of them. We may get one good one, so depending on what's bad in them. So I'm not sure when these were made. These are probably a few years old. This is the Yamaha RX V379 receiver, and I'm driving it here with 1 volt input at a frequency of about a kilohertz, and I've got the output connected to my dummy load. I'm measuring the RMS AC voltage across one of the channels here, and I have both channels connected to a scope where I can monitor the output signal. So I'm going to start increasing the volume here, and if you notice, as I bring the level up, pretty soon you'll see flat topping. Right there it's flat topping. I'll bring it back down. Right about there it's still linear, and we're looking at 23.7 volts RMS. And that is a little over 70 watts, which is what the rating of this amplifier is. I don't want to drive it too hard. Still pretty cool. I'm going to bring it back up. And we've got a, let's see what the distortion is. 0.3%, 0.23%. I think the rating is 0.9% for THD. So this amp is working pretty good. Here's the second Yamaha RX V379, and this one is dead, and I don't know what's wrong with it. Now a minute ago I plugged it in. It went on for a half a second and then shut off immediately, and now there's nothing. So I guess this will be another video, is a repair of this unit. I got two of these. The other one works perfect, so I don't know what's wrong with this one. This one has a nasty ding in the top here. Must have been when it fell in the dumpster. I don't know. Anyway, that was just a few basic procedures you can use to test your amplifiers, either when you get them in new out of a dumpster like I tend to do. You can connect them up to dummy load before you connect them up to your expensive speakers. So I hope you got something out of this, and I hope you enjoyed it. Thanks for watching, and we'll see you in the next one. Bye for now.